Hello, in this video we will talk about analytics. The term analytics has replaced other terminology used in the past for individual components of a decision support system. We now use the term analytics to cover all these decision support systems, EIS, expert systems, business intelligence, etc. It refers to the process of developing actionable decisions or recommendations for actions based upon insights generated from historical data. I would like you to note the word historical data. In essence, we can say that analysis of historical data can help us gain insights about the future. Now, if you look at the definition of analytics given by Informs, you'll notice that it says analytics is the combination of computer technology, management science techniques, and statistics to solve real problems. The interesting thing here is bringing in the computer technology to indicate how valuable the use of technology is in today's analytics. If you look from a decision making perspective, business analytics is the process of transforming data into insights for making better decisions, particularly data driven or fact based decision making. Let's have a look at 8 levels of analytics identified in a paper by SAS. So this file is available to you on As You Learn as a recommended reading. It talks about 8 levels of analytics. This was a report generated by SAS. So the 8 level of analytics are not all created equal. You can have different levels such as standard reports, which help us answer questions like what happened, when did it happen, and you can go all the way down to more advanced statistical analysis, forecasting, predictive modeling, and optimization. Now, the majority of analytical offerings available today fall into one of the first 4 areas, such as this. And these report historical data on what happened in the past, but no insights about the future. For most simple business problems of today, these analytical solutions will be all you need. But if you are asking more complex questions or looking for predictive insights, you need to look at the second half of the spectrum and go to forecasting or optimization or predictive modeling. Now, going back to the slides, business analytics has 3 different levels: descriptive analytics, predictive analysis, and prescriptive analysis. The descriptive analytics deals with what happened. Predictive analytics deal with what will happen, and prescriptive analysis goes a step further and talks about what should I do about it. In summary, we look at all the data to understand what is happening, what will happen, and how to make the best of it. It suggests that So this picture talks more about 3 different types of analytics. It suggests that these 3 different types of analytics are somewhat independent steps, and one type of analytics application leads to another. It also suggests that there is actually some overlap across these 3 types of analytics. It means some of the techniques that may be used for predictive analytics may also be used in descriptive, or some of the prescriptive analytics technique, for example, optimization, may also be used for prediction. If you talk about looking at implementing these 3 different levels of analytics, we can do a risk and reward analysis, and you will realize that descriptive analytic techniques usually cost less and are less riskier compared to the other two, but can only help us solve well defined or structured business problems. So you get lesser rewards as well. The next level up is the predictive analytics, which have a slightly higher risk in terms of implementation and cost, but they also have a higher reward potential and can help with accurate projections of future events and outcomes. Lastly, prescriptive analytics usually cost more and are riskier, but have the potential to help more complex decisions Let's talk about each one of them in a little more detail. So, descriptive analytics focuses on answering the questions of what happened based on a retrospective analysis of historical data. So, a natural first step is to make sure that we have data ready to be analyzed. For this, you may need to gather relevant data from various sources, clean it up, make it in a standardized format, and consolidate it. Usually, the development of this data infrastructure is part of the data warehouse. A data warehouse is a central repository of information that can be analyzed to make more informed decisions. Some of the topics that we'll cover in this course will include online analytical processing or OLAP tools, data warehousing. We'll also cover data visualization, some of the techniques using that. So, visual analytics, we'll be looking at some dashboards and scorecards. We'll be spending some time with descriptive statistics such as frequency distribution, histogram, variance of data, standard deviation, mean, median, mode, etc. In predictive analytics, we look at past data to predict the future or what is likely to happen. Some of the enablers are data mining techniques such as clustering and segmentation. We can also look at mining text data or web mining, forecasting, simulations, etc. One application of data mining can be to predict customer churning. Let's take a telecom company, for example, such as Verizon. You may want to know if a customer will switch over to a competitor or churn. Some of the inputs of building a predictive model for this can be what plan they are on, how much data are they using, how much is their monthly bill, number of customer service calls they have made in the past, maybe customer satisfaction surveys, etc. You may develop a predictive model or how likely is this customer to move to a competitor. And then, depending on that, you may want to give them some promotions or discounts. You may also use a segmentation technique to group customers into different segments based on common or similar characteristics and target specific promotions to them. We'll learn more about this as we go through the semester. Prescriptive analytics aims to determine the best possible decision by considering all relevant factors. This type of analysis yields recommendations for the next steps. It uses both descriptive and predictive analytics to create different alternative solutions and then determines the best one. These recommendations can be in the form of a specific yes no decision for a problem or a specific amount, such as a price for a specific item or airline fare or a complete set of production plan. For example, you may like to determine if you should continue a product line or discontinue it. Another question you may have is, let's say you have three different products A, B, and C, each requiring specific resources, maybe a mix of different common resources, and making different profit margins. You may like to know how many of each product should you make to maximize the profit. These kind of questions may be answered with optimization techniques such as optimization models or simulations. We will learn more about this towards the end of the semester.